Hi, everyone. My name is Jason Paulson, and I serve as Executive Director at the Methow Conservancy. And with me today, virtually, is local forest ecologist Susan Prichard. Hi, Susan.
Hi.
If you don't know Susan, you'll be impressed to know that she has played a leadership role in over 30 professional research publications, ranging from her most recent study, which we're going to talk about here today, to an early piece on the neurohumoral modulation of the feeding organs of clams, work that I'm guessing was inspired by her undergraduate work at the Evergreen State College, after which she went on to the University of Washington to complete her master's and her doctoral work. We're really fortunate to have Susan as a resource to us in our community here at the Methow Conservancy. And forests and their managers across our region and country are fortunate to benefit not only from her extensive research and knowledge, but also her ability to translate that knowledge into ways that make it accessible and useful for the rest of us. Thank you, Susan, for being willing to talk with us today. And congratulations on your most recent paper in the Journal of Ecological Applications.
Thank you. It's my pleasure to be here.
So for those viewers who don't know you and your extensive work on forestry issues in our region, can you explain who you work for and what your position is?
You bet. So I'm a University of Washington research scientist, and I've now worked for University of Washington in this same position for about 16 years. And the nice thing about it is that it's in close collaboration with the Forest Service. Many people wouldn't actually know this, but Seattle has their very own fire lab associated with the Pacific Northwest Research Station. And we actually don't study very much fire in Seattle, shockingly. A lot of our research is focused on forest management, especially fuel management throughout the country, and decision support for prescribed burning and wildfire management.
Great. I know that you've got a long history here in Washington State, obviously with your schoolwork down in Olympia, then back up at Seattle at the University of Washington. Was there something particular about Washington State's natural history or ecology that got you interested in researching forest fires?
So my parents are quite proud of me, but they sometimes joke that they did a little bit too good of a job at getting all their kids out in the woods. So my sister spent most of her adult life in Yosemite National Park, and I spend as much time as I can out in the mountains and in the forest. But one of the things that was really formative for me as a young person was that as we drove into sites within Olympic National Park and North Cascades National Park, we passed by a lot of logging. And back in the day, a lot of that was logging old growth forests. I loved that ancient forest of the Pacific Northwest. And when I was 13, I was particularly just impacted by all the news of accelerated logging in old forests, and decided I wanted to do something about it. And so that's when I decided to become an environmental scientist, once I figured out that that's maybe what you could do.
Oh, that's great. And I know your PhD thesis work brought you close to the Methow, looking at the history of fire and vegetation in North Cascades National Park up in the Thunder Creek watershed. What did you find out in that work about the history of fire frequency here in the North Cascades, and any other takeaways from that work that folks
You
might
bet. Yeah, I mean, looking back, I'm a little bit surprised that that's where I ended up doing my research, because ironically, my parents took me on my very first backpacking trip when I was 7 or 8, right around that time. And they actually took our 2 old Volvo station wagons. One of them we parked at Easy Pass Trailhead, and the other one at Colonial Creek Campground. And then we hiked up and over Easy Pass and then down through Thunder Creek watershed. So by the way, I did not find Easy Pass easy, and I told my parents that a lot, both during and after. So fast forward 20 years, I ended up deciding to do a couple of different fire-related research projects in Thunder Creek watershed. And the main reason why is that I had this really inspirational professor, Linda Brubaker, who studied paleoecology, so long ago ecology. And she made use of lake sediment records. It turns out that my very first summer of my PhD program, I got to hike in national parks. We had brilliant funding where basically my PhD advisor had funding for us to be in a national park and study climate change related things. And then after that, kind of the sky was open. And so after actually swimming, not just swimming, but skinny dipping up at 4th of July Path, there's these 2 little panther potholes. I had great memories of that experience and found myself back in Seattle listening to one of Linda's graduate students talking about what makes a really perfect lake for long-term reconstructions of fire and vegetation change. And it turns out that those lakes that we visited in were perfect. So that's actually why I ended up at Thunder Creek Watershed. And I've always been fascinated by fire as kind of this really important ecological process, but in a time of rapid climate change, fire is also a catalyst for change. So it can literally clear the slate, kill all existing mature trees, and then they have to survive through regenerating in what might be a warmer, drier climate. And so we often think of fires as really big change agents. And so I looked at lake sediments. There were actually 30 feet of lake sediments to sift and sort. Each centimeter represented 10 years, as it turns out. And I was able to reconstruct 11,000 years of fire history that really kind of help us understand how fire and vegetation interact. And hopefully we can use the past to inform the future. Yeah.
Wow, that sounds like a really fun project.
It was tedious but fun. Yeah.
So you've known the North Cascades your whole life, but was it time spent on that project that helped cause you to discover the Methow and decide you wanted to be here full time?
You know, I was raised on Whidbey Island, and I still feel like I've got that kind of imprint. The smells of the Puget Sound still feel like that native home. But my partner, Julie Grelu, and I recreated quite a bit over on the east side, and she was the one that convinced me that I could go a little bit warmer and drier in my habitat.
Yeah. Great. I know more recently in your career, you've done research up on the Tripod Complex fire area, looking at the effectiveness of different fuel treatments, thinning, prescribed burning, and combinations of the two. I'm curious what you've learned from that work that you found interesting or insightful as we look to the future.
You bet. So when I think back on a lot of my research questions, they really are grounded in climate change. And on the west side, I was interested in kind of big stand replacing fires and how those interact with how vegetation returns, especially trees. And then on the east side of the mountains, what I've become really passionate about is the topic of how do these forests remain resilient to not only fire, but also insects and disease and drought. And that often comes now during these times with management. So we're kind of at this really important crossroads where many of the ecosystems that are right outside our doors in the Methow Valley are fire dependent. They historically had really frequent fire every 5 to 25 years that maintained low fuels in the understory. So what we mean by that is that fire was kind of a good tender. This was either through lightning strikes or the Methow people also used fire a lot. And the fire would burn grasses and shrubs and tree needles and maintain kind of low fuels so that when the next fire came, it was often quite benign as well. And so that process of fire ended up reinforcing resilience. Well, we've had a lot less fire, partly through displacement of Methow people and partly through Smokey the Bear putting out fire locally and elsewhere. And so we're now in a situation where our forests are not resilient to climate change or fire. So when the Tripod burned, I thought it was going to be the largest wildfire event that I would ever live near. I couldn't believe the size of it. And we often talk about fire effects as severity. And so in that particular fire, we estimated that over 60% of the 175,000 acres burned as stand replacement. So the trees were killed in over 60% of the area. It's a big number. We're now used to seeing really high severity fire events around the Methow, but in a lot of areas, fire tends to be more mosaicked and leave patches of surviving trees and have different effects. And so I was really concerned about the tripod and what a big imprint it had. And speaking of a stand replacement fire that opens up a lot of area for change, tripod was that. Now there's some exceptions though, which is that if you look at satellite imagery after the fire, you see some funny green islands in the middle of what was a lot of stand replacement fire. And a lot of those were old treatment areas. So the Methow Valley Ranger District had either gone in back when they were doing clear cutting and logged the trees and then did a site prep burn. And so then they planted the trees in really kind of open conditions. Those old clear cuts look like funny little postage stamps in the landscape. I'm not that interested in clear cutting, never have been. And so I didn't focus on those. I focused on the areas that had been thinned and prescribed burned. These were Douglas fir, ponderosa pine sites. And what we found is that areas that really had been thinned and then leaving the larger trees and then prescribed burned had really high survivorship. So trees over 8 inches and higher in diameter, over 75% of them survived the wildfire event, which is really promising.
Oh, that's really interesting research. Mm-hmm. And then fast forward, there you are thinking you've seen the biggest fire you'll ever live anywhere near to 2014 and the Carlton complex fires come to town. And in this most recent paper that was published in February, I understand that you again evaluated the effectiveness of fuel treatments and looking at their role in determining fire severity. But you also added a new variable looking at fire weather and how it related to the effectiveness of those treatments. Can you explain to us a little bit about what was different about this study, the concept of fire weather, and kind of how you think about that when you study a fire like Carlton?
So, fast forward 8 years, and here we have the Carlton complex. And in some ways, when I talk about the Carlton complex, I could start crying easily. It was devastating for our community. And I still feel, I'm sure you probably feel the same way, that there's trauma involved in that large of a fire and how impactful it was for our community. And so it actually took me a couple years to just get the gumption up to apply for funding and do some research. But it also, and this is a little bit humorous, represented humble pie for me as a research scientist, because I had published a pretty good article on the tripod that was published in a good journal, Ecological Applications, saying fuel treatments survived a really extreme wildfire event, and I was talking about the tripod. And I mean, the tripod was not an extreme wildfire event compared to the Carlton complex, like that was extreme. And so for me, I felt like it was really important to come back to a very similar question and say, all right, we got this crazy event. It exceeded a lot of fire behavior analysts' expectations. For instance, during the big fire spread day, fire behavior analysts used models, ran thousands of simulations, and of those thousands of simulations, only 2 actually met what the Carlton complex did. It was just crazy fire behavior. So when I kind of thought about the fire behavior, I thought, like, this is the ultimate test of field treatments. We all saw that huge plume of smoke, and that plume of smoke was not just smoke, it was burning embers and it was preheated air. You can imagine as that smoke is shifted over, the column of smoke is shifted over by strong winds, that it preheats and almost cooks fuels ahead of it. So I didn't expect that anything in the line of fire for a wind-driven fire event would survive well. And so I expected that we would research fuel treatment effectiveness and not find it. So, yeah.
Interesting. Just fascinating to have those two examples right next to each other and literally adjacent to one another on the landscape.
Right.
And so as you did that work, what did you learn from the Carlton research about those fuel treatments and their role or impact on fire severity under those very extreme conditions?
I wish we could actually view a map. It would just be really fun to kind of show everyone, and we should do this once we can all gather again. But we found some really promising results. Sure enough, not surprisingly, any fuel treatment that was facing the wind of the Carlton complex, and I'm just going to kind of remind you, but I'm sure all of you remember, on July 17th, 2014, the winds were over 30 miles per hour sustained. And they also just drove that wildfire. In a 24-hour period, it burned 167,000 acres. And the tripod fire, in comparison, was 175,000 acres total. So we had this one-day event where the wind-driven fire was crazy. So anything facing that fire, where the winds aligned with, you know, like we're pushing that fire into it, and again, that preheated column of smoke was preheating those fuels and allowing fire to be really intense there. Those treatments didn't work. No surprise there. But I think many of you will remember that the fire was so intense that it actually skipped from ridge to ridge at times. And yeah, it was so wind driven, and the embers were lofted into this massive column of smoke that you could see up at Pipestone Canyon was a perfect example of this, where you saw a big run up a slope facing the wind and then a skip over to the very next ridge. Well, it turns out that the leeward slope, so the slope away from the wind, was a good bet for those thinning and prescribed burn treatments that were on the landscape. And so the treatments that happened to be in the shadow of the wind fared really well. And so maybe not like that shocking for us, it kind of makes a lot of sense, but given that the winds were very predictable, they were going down valley in a summer wildfire for us, that gives me a lot of hope that managers can potentially anticipate summer winds like that again and start thinking about, like, where are we going to hedge our bets? Where is a good place to put in field treatments? Now, one of them happened to be a 2,000 acre thin and prescribed burn near Leecher Mountain, Benson Creek area. That was a game changer in this wildfire event because it happened to be, again, on a leeward slope, and the fire was marching its way very quickly to the Columbia River, met a big slope change, hit this treatment, and then there's actually a huge donut hole, as they call it, in the middle of the fire. That was that one treatment, actually, I think, made a huge difference. And so the fire didn't spread into a lot of forest there.
Wow, that's fascinating.
Yeah.
So
there took a lot of, sorry to just interrupt, but a lot of firefighting went into protecting that area after that big event, but it gave them that opportunity. Yeah.
Yeah, no, that's great. And it seems, having lived through several fire events now, it does seem like our prevailing winds during a fire event tend to be from generally the same direction. And I suspect that might be true in other mountain communities across the West as well. So it'll be fascinating to see how fire managers take the information you put together and bring that to the design of their treatments and how they prioritize work out on the landscape. That's really neat.
Absolutely. Meg Trabon, who used to be the assistant fire management officer for Methow Valley Ranger District, once said, "You know, Susan, you could never fireproof a forest." And I like that quote because it really does say that I think these treatments are worth it, but we don't know that they'll always work. We don't know always where the wind will go. We can just kind of hedge our bets and use probabilities, and again, kind of that past to instruct the future as we plan.
Yeah. So as I was reading your work, I was curious about whether any of that research translates down to our individual levels and our home sites down on the valley floor as we think about firewising and, you know, preparing our homes or our neighborhoods for events. Do you think any of that knowledge translates? Like, should we be thinking about where on our lots we either do field treatments or maybe even where we site our homes?
I have so much to say about that. I'm pretty passionate about it. So first of all, what we do within the 30-foot defensible space around our homes matters a lot. And that includes making sure that our homes are not ember traps. So there's a lot that we can do with decking and siding to make sure that if there is a wind-driven event like the Carlton complex with a lot of live burning embers in that event, our homes are not so flammable. So that's one, really important. Number two is that I hope that people don't convert their backyards to gravel piles. Like, that would work, but that's ugly and it's not good bird habitat. There's a lot we can do to, just like a field treatment out in the wild, out in the kind of broader forest. I think we can really work with our native landscaping to make sure that it's not so continuous and flammable. And so what I really recommend is making sure that the understory fuels are very limited and sparse. That might involve raking. It could even involve some little prescribed burns. And I'm hoping that we can consider a little bit more of that in the valley over time. But in general, basically making sure that there's not a lot of flashy fuels near our homes works. So.
Oh, that's great. And timely advice and instruction in spring, and looking forward to yet another fire season ahead.
I know, yeah.
So thank you for that. I'm curious, sort of, you talked about your work in Thunder Creek and, you know, looking back 11,000 years and sort of what changes occurred on the landscape in terms of vegetation in that context. Is any of your work continuing to look at the Carlton complex fire and changes in vegetation there going forward? And has it been long enough to learn anything yet?
Not yet. So I've been really fortunate to partner with Connie Mamel, Darcy Dickinson, and David W. Peterson. I always say David W. Peterson because my graduate advisor was David L. Peterson. They know each other. But anyway, we were able to put in a number of plots. I forget the total number following the Carlton complex. These were monitored for 3 years to look at post-fire tree mortality and initial vegetation recovery. We're really hoping to get funding to do that every 10 years. It does not make sense to look at tree regeneration immediately following a fire event, especially for ponderosa pine. It tends to need specific kind of like a window of opportunity to regenerate. There are some areas that we already know that are going to be pretty high and dry for tree regeneration. So Benson Creek, where the fires were really intense, I don't know if we're going to get ponderosa pine coming back. They might be long-term grasslands. Similarly, Upper Finley Canyon, I worry about, just because if you go up to South Summit Road and you look down the canyon, I don't see any live trees. So without planting, it might take a long time for those forests to recover just because of seed source issues. So it really depends on where we are, and it will take some time.
Yeah, it sounds like we have a lifetime of research opportunity literally right in our backyard.
Fire is the proverbial hot topic, and I would say that I'm good. I'd rather not see a lot of big fires again in the Methow anytime soon. I think we've had more than our share, but I'm afraid that we all need to kind of consider that it's not if fire comes, it's when, and fire is definitely going to be part of our lives.
Yeah, no, thank you for that reminder. And before we close today, are there any other take-home messages that you would want to share with the community, either from your most recent research or your work in general, studying fires and its impact on our landscape?
Yeah, it comes back in a way to just that long-term perspective I got from coring those lake sediments in North Cascades National Park. So 11,000 years ago on that site, it was a very different vegetation type. Actually, this is hard for us to imagine in an era of rapid climate change, but 11,000 years ago, summers were actually warmer and drier than they are today. It's kind of shocking, but true. I'm going to spare you the details about why, but we know a lot about how vegetation started adapting to that drier climate and more frequent fire. And so I want to leave you with this kind of hopeful message, which is that right now, our forests are not well adapted to fire, but I think that if we can all get behind a lot of restoration, and unfortunately we have to actually use fire to get there, but we can envision a more resilient Methow and bringing back more resilient structure and bigger fire hardy pines around this ecosystem. They're adapted to fire, they're adapted to drought, and I think we can get there with a lot of good collaborative work.
Great. Well, thank you, Susan. It's nice to end on a hopeful message and thinking about the ways we can have a positive impact on the landscape. I want to thank you for spending time with us and sharing your expertise today, and look forward to when we as a community can all gather again back in the barn, because I would love to have you back and to go a little deeper into some of those whys and some of what you learned back at Thunder Creek to put our experience into that historical perspective. So, well,
I look forward to gathering at the barn too. I noticed that they're taking this time to kind of reconstruct the entrance of the barn. So yeah, we can hope for that day sooner than later. So
yeah, no, that's great. Well, thank you very much, Susan, and we'll look forward to seeing you out on the trails very soon. And for everyone else, thanks for tuning in again this week, and we'll look forward to seeing you in the future. Take care, all.
Thank you.
Okay, I have